if a square, it's like a 3 by 3 square, has area 9, if I draw a diagonal here, that diagonal's length will be 3 root 2. Now if I make a square on that, 3 root 2 squared is 18. So that new square is double the area of the old one. And a cool way to kind of see that is you just draw these two diagonals and color this red and this green and this green. So that's called doubling the square. But doubling a cube is much more difficult. So here's a cube of volume 1. A cube whose volume is double would not have double the side. 2, if this was 2, 2, 2, that would have volume 8. Instead, if the volume is really 2, each of these things is just slightly bigger than 1. It's the cube root of 2. And creating a line segment whose length is cube root of 2 is called doubling the cube, and it can't be done with a compass and a straight edge, but it can be done a different way. There's a concept in math called finding two mean proportionals. So there are two numbers, and just to tell you so you know what's going on with this, 8 over 12 equals 12 over 8. 8 over 12 is 2/3. Eight over 12 is 2/3. Yeah, equals 12 over 18 equals 8 over 27. These are all equal to 2/3. You can test it. So finding those two numbers, though, is called finding two mean proportionals. And it's very easy to calculate the x and y. It's always the same. It's always the same thing. You cross multiply here to get x squared equals 8y, and you cross multiply these to get y squared equals 27x. Then you solve for y in terms of x squared over 8, and you substitute into this y, so you get parentheses x squared over 8 squared equals 27x. This becomes x to the 4th equals, let's write 64. 8 squared becomes 64 times 27 times x, or x cubed equals 64 times 27, which makes x equal 4 times 3, which is 12. And once you have x figured out, you could plug it into here. 144 over 8 equals 18. So that's how you find two mean proportionals. Now, if I'm trying to find two mean proportionals between 2 and 1, I get x squared equals 2y, and y squared equals x. Y equals x squared over 2. Substitute that y into here. X squared over 2 squared equals x to the 4th. Hold on a second. Let me do this with the 1, and that's probably a little better. Equals y over 2. So x squared equals y, and 2x equals y squared. So y equals x squared, so I can substitute that in for here, get x squared squared equals 2x, or 2x equals x to the 4th, or 2 equals x to the 3rd, or cube root of 2 is equal to x. So the way we can use this is if instead of solving this with algebra, I graph these two things. So I'm graphing y equals x squared, and x equals y squared over 2, or 1/2 y squared. When you graph these, y equals x squared looks something like that. And x equals y squared is a sideways parabola, but x equals half y squared is kind of a wider one. If you can create this intersection point, the x-coordinate of it will be the cube root of 2. So if you can create these things, you could double the cube. The spiral of Archimedes can be used to square the circle that's making a circle as the same a square that is the same area of circle of a given circle. And the way we do that is we need, let's say I want here's a major property. If I can make a tangent line to the spiral, and I connect it, the tangent line, the point of tangency that is, to the center of that circle, and then from this point I make a right angle, this line segment here will always be the same length as the arc. If I go from here and make a circular arc in this direction till it hits this horizontal, these two things, this green and this green, will be the same length. And I'm not going to prove it, I'm just going to tell you that. But if that really is true, that means that if I have my spiral of Archimedes and I make this really kind of long, here's the tangent line, and here's my right triangle, then this line segment here will have the same length as this entire, if it gets to the end, it's the entire circle. So if this circle was, let's say the radius was 1, so the circle is 2 pi r, so this line segment is 2 pi r also. Well, I want to get pi r squared, so I'm just going to take the midpoint of this line, so this is a half now, and make a rectangle. So r over 2 times 2 pi r is pi r squared also. And then if I want, I could do that to make the square by squaring this, the rectangle as done before. So spiral of Archimedes could be used to square the circle. And finally, if you have a circle, quarter circle here, and here's a square, and I make a horizontal line segment, and as it moves down, this radius rotates clockwise. So when it's a quarter of the way down, the angle will be a quarter of the way through, and we'll have a point here. But when it's halfway down, this angle will be sort of halfway, so there'll be a point here. And when it's 3/4 of the way down, this angle will be sort of 3/4 of the way down, be a point here. We get this curve, which is called the quadratrix of Hippias. And that curve has some interesting properties. Suppose I have this square here, and I have the quadratrix. Here's the quarter circle, and I want to trisect this angle here. All I have to do is make this line segment. See where the angle hits the quadratrix. Make this line segment. Trisect that line segment. Go horizontal. Find the points on the quadratrix so that this line segment is also 1/3 of this one, and you will have trisected the angle, because any time the line segment is proportional to the angle, or double the line segments, double the angle. So we can trisect an angle with the quadratrix. And finally, I have a circle, there's the square, there's the quadratrix. It turns out that this line segment here, if this is the radius, that line segment will always be equal to 2r over pi. So if I really have that line segment, I can take the midpoint of it, and this line segment here will be r over pi. Let's just move that guy over here. So if that line segment is r over pi, and then I make a perpendicular side equal to r, and then I make another r over here, and I connect this, and I make a big parallel line, and do this. This side over here, these triangles are similar triangles, so I can say that the short side over the bigger leg is equal to the short leg over the bigger leg. When you cross multiply, you get r squared equals r over pi times question mark. Multiply both sides by pi over r. and you get question mark equals pi r. But this is r, so that means this entire rectangle would be pi r squared. And then, if I really want to, I could square that and use this side here. I can make a square there, and we would have squared the circle.